everybody, for this week's lab, what we're going to be doing is we're going to be characterizing oxygen dissociation curves for two respiratory pigments. Hemoglobin, we're going to work with hemoglobin from cow blood or bovine blood. And then we're also going to characterize dissociation curves for hemocyanin from our horseshoe crabs. So for conducting this work, one of the things we have to do is we have to expose the pigments to environments that have different oxygen concentrations in them. And then we're going to measure changes in the color absorbance of the pigments after exposure to those different oxygen concentrations. So that might lead you to a question of, well, how exactly are we going to do that? And what we're going to do is we're going to use a device that looks like so. That's called a tonometer. And what this is basically we've got a test tube down here that will fit into our specs. And then up above that we've got an air chamber space. And we can control the gas composition in this air chamber through these two openings that you see on either side. So one of these has a stopcock to it. And so if you kind of look down the tube when the stopcock is open, you can see a clear opening down into the tonometer. And then on the other side, we can close this off just using a rubber septa that looks like so, that will fit into the end of the tubing. So then when we reach a point where we are ready to manipulate the gas composition in here, what we're going to do is we're going to start out with a stopcock open. And we're going to take some pure nitrogen gas from a tank, which I'm going to take you over to in a moment, and we're going to flow air from that nitrogen tank in through this opening for a long enough period of time so we know we've flushed out all of the air that had been in here. And then as soon as we're done flowing that nitrogen through, we're going to go ahead and close the stopcock and put in one of these rubber septa, and that will seal our chamber with no nitrogen in it. So at that point, or 100% nitrogen in it. So at that point, basically that condition, the oxygen partial pressure gradient will favor dissociation of oxygen from the pigment into the air. And one other element with that is our pigment is going to be in a solution in the tube here, but of course diffusion into a liquid itself is very slow. So one of the things we're going to do to facilitate equilibrium between the gas that's above the liquid and the liquid itself is I'm going to have you take the tonometer and tilt it on its side so that the liquid is in the bowl of the tonometer, and then you're going to swirl, or you can just kind of tilt back and forth to get the liquid and the gas to equilibrate with each other. Once that's happened, you've got your deoxygenated pigment, then you're going to go ahead and take that and take an absorbance reading on a spectrophotometer. For some reason, this only works with an older set of spectrophotometers that we have here in the lab. So I'm going to take a minute to just kind of show you how that all looks, because it's a little different from digital specs that you might be more accustomed to. And for doing this, I've got one tonometer that just has DI water in it as a blank. And then I'm going to actually use a fake solution with some red amaranth dye instead of using a respiratory pigment in this case. So I'm just going to go ahead and load that dye. Into my tonometer. And that's about the total volume that I'm aiming for. It doesn't have to be a precise volume, as you will see, but that should be good enough for the time being. So with these old specs, I'm going to give you a bit of a close-up view here. So what I hope you can see with this old spec is, so we've got the on-off switch. It's down here on the front. And these can take a little while to warm up, so you do want to get this plugged in and turned on pretty soon after you get to lab. Then you'll also see something down here. There's a wheel And this is an adjustment wheel for the absorbance and transmission. Then up on the front, right here we've got a dial for setting your wavelength. And then for your readout, we've got this old-fashioned needle gauge here that will show you your readout. And the thing to notice on this gauge is we've got two measurements here simultaneously. So up on the top is the percent transmittance, and down below we've got the absorbance. Okay, so what you're going to want to do here is first you need to select the correct wavelength to work with. So for hemoglobin, you're going to want to work with a wavelength of 625 nanometers. Okay, so this is currently set to 625 right now. So then I'm just going to open this up. I'm going to wipe off the outside of my tonometer so I don't introduce any liquid into the spectrophotometer, and this tube will actually just fit right on into the spec. And then the next thing I want to check is my needle position. At the moment it's actually sitting right at an absorbance of 0 or transmittance of 100%, which is where I want it to be. But if it is not exactly where you want it, that's where you can start to use this adjustment dial down here. So for example, if I increase the absorbance, see that needle go up. If I decrease, you'll see it go down. So you just want to make sure that it's right at 0. One other trick with these is sometimes the transmittance will be way, way, way over, right? So you may have to spin this wheel for a while before you reach a point where you will start to see the needle move. Okay, so now I've got that set to 0 with my blank. So then the next thing you need to do is check your starting measurements with your pigment solution. And right now, that pigment solution, I'm reading my absorbance down the bottom. And notice this is a logarithmic scale. So right now I've got an absorbance reading of 0.08. So for starting out with, as I note in your lab handout, you're going to want an absorbance that's right around 0.2. And the other thing that you're going to want to do is you're going to want to think for a minute about what you expect to happen to each pigment when you deoxygenate it. And more specifically, do you expect that pigment to get lighter or darker at your current absorbance? And it's worth it to take a minute and just write that question down. Do you expect hemoglobin to be lighter or darker when it is deoxygenated? And same question for hemocyanin, lighter or darker when deoxygenated? Because that's going to determine the direction of change of your absorbance reading, and that's part of why it's important to have a starting absorbance of around 0.2. So in this case, I would have diluted out my fictitious pigment a little bit too much for my initial measurement. Okay, so you're going to take an initial reading, while oxygenated. Then you're going to deoxygenate, and you're going to close up your tonometer. Then you're going to take some time to equilibrate your solution with the gas. And this is usually a good way to work on getting it equilibrated. Just pouring it back and forth. The equilibration step can take a while, so set a timer, give yourself at least 4 minutes, if not longer, to equilibrate. And then you're going to take another reading after you've deoxygenated. And then the next thing that you're going to do is you're going to start returning oxygen to your tonometer. So here's how you're going to do that. On your table, you'll also have a glass gas-tight syringe. So here's a 5 ml gas-tight syringe. also have a couple of 30 cc gas tight syringes. We're going to start with the 5 ml syringe. These are lure lock syringes, so these needles will just twist on, and then you can uncap your needle. And the first thing you're going to do is you can puncture this rubber stopper with your needle. Rubber is a self-healing substance, so it will close up around where the puncture is located. And then you're going to draw up a volume of air out of the tonometer. So in this case, I'm going to draw up 2 milliliters of air. I'm going to pull this, whoop, that pulled out too well. Pull the needle back out of your tonometer. Release that 2 mils of nitrogen gas. And then if you want, you can kind of go up and down a couple of times. It doesn't really matter. But then what you're going to do is you're going to take 2 mils of room air, go back in, you're going to inject that 2 mils of room air back into your tonometer. Take your needle out. You're going to take another 4 minutes to re-equilibrate. And then you're going to repeat your measurement for absorbance after having added back some oxygen. Past that point, you can start removing and replacing slightly larger volumes of air. So for example, on my next round, I might go ahead and pull out 4 mils of air and replace that with 4 mils of room air. Along with all of that, one thing that will be useful to know is the total volume of your tonometer, so you know when you've gotten fairly close to replacing a lot of the air that's in here. One other tip with needles. So in this case, we aren't using the needle to puncture skin, and so in this case, it's acceptable to reuse these needles, but we still need to be very careful that we don't accidentally puncture ourselves with the needle at all. So the correct method for putting a cap back on a needle when you are recapping the needle is you want to put the cap on the table, and then you want to scoop the cap with the needle and then come in at the base to tighten it and put it back on again. So that way you're not at risk of stabbing yourself at all with the needle. And then these needles will just twist off of the lure lock. So I also want to take a minute to show you a couple things about using the nitrogen compressed gas, just in case you haven't ever interacted with compressed gas before. I will most likely be supervising this step directly, but I think it's helpful to understand a little bit about how to safely operate gas tanks, and also to be made aware that there are a lot of fairly substantial safety hazards with working with compressed gas. The biggest risk is that gas is compressed, and so if something were to happen to cause the top of this tank to shear off, basically it turns one of these heavy metal compressed cylinders into something of a torpedo. So to prevent against that risk, compressed gas cylinders should always be kept stored secured, so there's no risk of them falling over and having the tops sheared off. Next up, a compressed gas cylinder usually has a main valve, but this main valve doesn't give you much control over the gas flow rate. So instead, the gas flow is controlled over here by a regulator. And this regulator has 2 components, 2 dials to it. So the innermost dial tells you the gas pressure when there's no gas flowing. And then the outer dial tells you the flow rate of the gas from the cylinder. The flow rate's controlled by the knob that's illustrated right here. And these actually operate backwards to what you might expect. So when you're first getting ready to start flowing some gas, what you want to do in general is just make sure that this is completely off. So I'm going to just check it by turning it in the counterclockwise direction. That's all the way off. Then once that's off, the next thing I'm going to do is I'm going to open the main valve. And what you'll see is this tank still has a fair amount of air in it, so it has about 2,500 liters of air remaining. Once I've done that, then I'm in a position to start slowly opening the regulator to start flowing gas. And we don't really need a very strong flow. When the gas starts to flow, you should start to be able to hear it hiss a little bit, and often you can feel it if you just blow it against your skin. When you're at that point, again, you're going to make sure that you have your stopcock open, so the gas has somewhere to escape. And then in the other opening to your tonometer, you're just going to put this into the end of that opening. And to ensure that you've flushed out all of the room air that's inside of the tonometer, you're going to wait for about 90 seconds while you're flowing. And even now, this is probably too high of a flow rate, so I'm actually going to turn this down a bit. That should be totally fine. So you're going to do this for about 2 minutes. Pull this free, put your stopper in, close your stopcock, and you're good to go. Then when you're finished with the compressed air, what you want to do is first turn off the main valve, and then that's going to let the remaining air flow out through the regulator. So you can see this dial starting to go back down. You can even open this up further, and then just make sure your regulator is left turned off. All right, so the last thing we need to do is just a quick rundown of our treatment groups for this project where we're characterizing oxygen dissociation curves. So we're working with two different respiratory pigments, right? So we've got hemocyanin, and we've got hemoglobin. And then we're also going to be looking at two different pHs, so different levels of acidity. So we're going to look at a pH of 6.6 and a pH of 7.6 for each of those pigments.